Okay, Assalamu alaikum, welcome back. This is the last topic of our course. A very critical topic. I think we hear about it in the news all the time. And as you know, also recently, Qatar and the region is under a lot of attacks, security attacks. So as developers, we have really a big responsibility to really be aware of these threats and build our applications in a way to avoid them. It's quite challenging because sometimes we're under a lot of pressure to just deliver a functional software. Of course, all the deliveries that we have done so far are very insecure, as we will see shortly. But that wasn't our focus. Towards the end, at least, what we want to do now is to at least be aware. What are the dangers or the threats that are out there targeting web applications? And we will focus on what are known as the top 10 threats. There is an organization called OWASP, which is a non-profit organization. And what they do is every year, not every year, every 3 years, almost every 3 years, they do a review and they collect input from people, developers, and experts. And they come up with the top 10 threats that are targeting web applications. And then they give guidance and they give tutorials and best practices on how to avoid them. So that's what we will do. So before I move forward, what I want to show you is as developers, traditionally, these are the things as developers we worry about when we develop our applications. Of course, the scope of security now is much beyond this. But the minimum is you find yourself as a developer, you always worry about authentication. And what is the goal of authentication? Yes. Yes, it's verifying that whoever is like basically someone is claiming to be the administrator or the coordinator or the student or the parent. You try to say to them, "Hatu burhanakum in kuntum sadiqin." Okay, you try to say, okay, give me evidence that you are what you're claiming to be. And typically we use, of course, the simple way we use password, but there are, of course, much more sophisticated ways of doing it. It could be fingerprint, it could be certificates, it could be special cards that have some kind of authentication token that get transmitted. So for example, if you go to the immigration department, I think in the admin building, in front of the QNB, when they go to do some immigration transaction, like renew somebody's residence or issue a residence for someone or do something, they authenticate using a special card. Maybe it's integrated with their Qatari ID or something. So it's not only username and password. It's something much more sophisticated. But regardless of which mechanism you use, at the end, authentication tries to make sure that the user is he or she claims to be. So you establish their identity. You know who they are. Because based on who they are, what this will determine for you? Yes, or what they can do. Yes, the privileges, thank you. So because the privileges are associated with the identity. Okay? And usually privileges are not assigned directly to identities, but they are assigned to, typically a good practice in security, we assign privileges, is it to individuals or to something else called, types of users, very good. What do we call them usually? Role, R-O-L-E, a role. So each individual user, they have a role. They play a particular role within the organization. Maybe they are coordinators, maybe they are instructor, teacher, So for example, Banner, it does not manage every individual. Say, oh, this is Fatima came in, this is what she can do. That's not how it works. So it's when let's say Fatima logs in, oh, Fatima is a student. So let me give her all the privileges associated with student. Okay? Or if somebody else, like let's say a teacher one authenticates and comes in, and we know what is the role of this individual. Okay, they are instructor. Then the system will give them all the privileges associated with instructors. Why typically we manage authorization? This is basically called authorization. That's the next step. Once you do authentication, the next step is authorization. So authorization grants privileges to users. But when you configure these privileges, you typically assign them to roles, not to individuals. Why do you do that? You manage authorization role-based authorization, not individual or account-based authorization. Yes. So basically, it's easier management of security. So you just have, within an organization, you only have a couple of roles. Let's say there is a worker, manager, HR manager, director, president. And then when you manage authorization, you give access and privileges to these roles. And then you assign people to these roles. Because people do change, as you might notice. They move from one role to another. So when they change, we just change their role, and suddenly their privileges will change. That's it. Okay? So that is the basic idea of authorization, assigning the right privileges to roles. Very rare to users. It's not a good idea to assign them to users. Otherwise, every time you have a new student, you have to create their accounts and give them privileges. And if you change, you have to go and change all the students' privileges. But if you do it smart way and say, okay, I have a role called student, and maybe I can even distinguish undergraduate student from graduate student, for example. And then I say, this is what the undergrad students can do, this is what the postgraduate students can do. And then when I have a student coming in, when I create their account, all I do, yes, I basically assign them a role. And then they will, from that role, they get the privileges. Okay? So that's basically it. The third thing that we usually care about as developers is this concept of confidentiality and integrity. Of course, in our homeworks and assignments, this is our last concern. But in a real application, for example, you never store password in clear text. You will always encrypt it because you never know. Somebody, even from internal, from IT, or somebody, somehow they hacked into the server, and they will get nice file with all the passwords and usernames. At least make it a little bit hard for them, and by encrypting those sensitive information. Credit cards, when you store them in this customer, and this is the credit card number, you don't just put it plain. If somebody managed to hack into that customer table, they just do select star, and they get all the IDs. So, and this confidentiality, we need to worry about both when the data is in transit, because there is a lot of people are watching over this. They put their sniffers over the network and sniffing what's going on. Even you saw with the browser, you can, with the simple plugins, not even plugins these days, it's built in, you can see the request and the response. So if you put your password in plain text in the login page, that's what we're doing, of course, your password is going through the internet in plain text. Anybody can hook in and do some packet sniffers and find your password very, very easily. Of course, as a security aware developer, you never do that. At least for the sensitive pages, you put HTTP, you configure them to use HTTPS. Sorry for this. To use HTTPS instead of HTTP. Okay, you get the idea. So you worry about this confidentiality of sensitive information, whether the data is in transit, which means it's moving from one location to another, or it is at rest. At rest means it is persisted in a file or a database. You make sure it stays confidential, usually through some kind of encryption. Okay. Of course, you have to do some kind of balance. You don't go and encrypt everything. Why is that? Why is that not a good idea? In what way? Oh, yeah, yes. Yes, because you have to decrypt, and that is computationally intensive, and it will slow down the whole thing. So you need to be selective. What is sensitive, you encrypt. What is public and not that sensitive, you just leave it as it is. Okay. So if somebody just looking for products through your website, it's a public information. Why should you encrypt it? But financial information, health records, personal information, yes, this is worthwhile encrypting, whether it is in transit or at rest. All right. There's another thing related to confidentiality. It's called data integrity. Okay. Yes, that when you send a message, the recipient has some mechanism to know that this message was not changed along the way. So, for example, you send a message to QNB to do some transfer. Let's say Qatar University sends every month, let's say, transfer to these guys, their account, how much transfer. Imagine somebody intercepting that file in the middle and changing the numbers and just adding some zeros. You know how the situation will be. So the recipient needs some mechanism to make sure the file or that message was not tampered with, was not changed along the way. So that's why you use something called signature. You sign the message. You don't need to encrypt it. So it's a less costly compared to encryption, but it serves a different purpose. You're not trying to hide or encrypt the message, but you're trying to protect it from change along the way when it's transiting. So these are the main concerns as kind of a development task. You find yourself as a developer dealing with these three major security development tasks. But of course, it does not stop there. This is like the minimum you should be aware of. But you know, there are a lot of kind of some bad guys out there, and they do all types of tricks to create problems, basically. So what the least they can do, some kind of web defacement. You know what this means? They go to your web page and they put maybe some political message or some inappropriate content, and people come there to your web page and they suddenly see this terrible stuff in your web page. And what this will cause to that particular organization? Yes, it will damage their reputation heavily. Okay, and so it's no longer trusted. So, for example, they might tap into their Twitter account, for example, and put some messages that never came from that organization. Or, you know, I'm sure you have heard of this a lot. So web defacement, it could be for political reasons or for like taking revenge from some organization. It could be for different reasons. Basically, go into the website and put in inappropriate content. These are common threats. We hear about this all the time. And we will see what it means, what are the mechanisms hackers do to achieve these, and how we can protect our application from them. The other thing that we hear about all the time is this loss of data confidentiality. So suddenly your credit card number is public. Everybody knows about it. Okay, or not everybody. Those hackers know about it. So that information disclosure, it could be like personal information, financial information, trade secrets, country secrets. For example, yes, it could be more. Those are more. Yeah, those are good examples. Yes, but it could be small scale at the organization level, or large scale at the country level. Yes. There is a data loss where they don't steal it, they just destroy it. That's all. So they just go to, let's say, QNB customer database and just destroy everything, and hopefully destroy, not hopefully, destroy the backups, destroy everything. They are not interested in taking the. Yes. Okay. So sometimes unauthorized access. That's another big threat. Like somebody, like this is your account, only you supposed to have access to it. Somebody tap in and start transferring to different accounts or buying on your behalf and enjoy life somewhere. Okay? Or denial of service. This is also very serious. Like what they can do is bombard your server with not genuine traffic, and the server will shut down or slow down, and the genuine traffic, your customers and your partners will not be able to come in. Okay? So it will reduce your availability, of course, your reputation, your revenue, and so on. So these are kind of results of attacks. This is what are kind of the impact from web defacement to information, to loss of confidentiality, to the loss of data, unauthorized access, or denial of service. Now, what are the techniques that these hackers use? Of course, it's a continuous battle between the defense and the attack. It's a non-stop. You find some pattern or some technique, you learn about it, you protect your application against it, and then few months or few weeks or few days, another technique comes up. So, but at least these are the most common techniques that are used to create examples of these threats or these results, undesired results, and impacts on your organization. So as I explained in the beginning, there is this non-profit organization called Open Web Application Security Project. And what they do, as I explained, is they collect input from experts, from developers, from companies, and they compile this list of top 10. Every 3 years, they update it. And then for every type of attack, there is a very nice, you just go to this URL, a very nice explanation of each one, what are the consequences, how to protect yourself against it. And then they can even give you some guidelines or guide how to protect yourself if you are a .NET developer or Java developer or Node.js. So they have a lot of projects around this, and all open source. And also they have what they call OWASP chapters. Every country or every major city, they have some monthly or yearly or periodic gatherings where they present this information, explain to developers and raise awareness about these attacks. So there is one also in Qatar. Sometimes it gets active, sometimes it dies off. Depend who are available to basically activate it and make it more active. These days, I think last year they came to QU, this OWASP chapter, and they gave a presentation, like a kind of a workshop, 3 hours workshop. This year they are a bit quiet, but anyway, we can do it ourselves. All right, so these are the top 10. So what I will try to do is to go through each one, give you an idea, my understanding of it. We have a little bit of discussion. Whenever possible, I will show you an example of what it means, and then we have a little discussion how to prevent it. Okay. So in here, it's more about awareness. Unfortunately, we don't have the chance to go to our projects and homeworks and fix these problems, but at least you are aware of them. Okay. So let's get started. So the first one, maybe some of you are familiar with it, is the injection. So anybody can explain what is it? Yes, please. Mm-hmm. Yeah. Yeah. Okay, yes, good. But it's not limited to SQL, by the way. Whenever you have some kind of interpreter, some kind of engine that receives a string and it executes that string, you have this risk. Okay. An example, SQL is just an example. So SQL is an engine that receives a queries as a string. Okay. And basically take these strings and executes them and give you some results. Sometimes it's just querying, it can do updates, delete, do all types of things. But this is just an example. You have other examples, like in JavaScript, there is a function called eval. This eval, you give it a string, and it executes a string that has JavaScript, and executes it for you, and gives you the result. So that is also subject. This is an open door for attacks. So let me just show you. This is very, very common and very, very dangerous. Whenever you see this type of problem, information disclosure, data loss, you will hear this in the news, most likely more than it's some kind of injection. Okay? So let me just show you a very small example just to give you an idea. If I just go to this service and go to this stuff, okay, in here, typically, how do you go about doing the login when you authenticate users? So you want to verify that the user is valid. So you add a where clause, okay? Where username equal, and typically as lazy developer, you will say equal plus some kind of parameter here, user name, okay? And you do something like plus, and you have seen this, and plus password, all right? All right? No, here, password equal password. Here it is a parameter, okay? Let me just put P here and P here, just to indicate. So in your program, you write some string like this, and the username will be coming from the user. Let's say you have a login box. You have two boxes. One you put username, and second one what you put? Your password, and then you submit. So you receive these two parameters, username and password, and then you concatenate them into a select statement, and you submit that to the server to execute. Okay? So you get the idea, is it? This is open for injection. Unfortunately, I don't have time to show you in code, but just imagine you give me, for example, you want to log in as CS. So you will send me a username. No, by the way, it will be something like this. Let me just, so you will do something like this, plus. Yep. So basically, you send me the username, so it will be CS. This is coming from the login page. And then you give me the password, which will be, let's say, password. All right. So this is the normal, that's what normal users will do. And they will, if you give me the right username, the right password, I find a match in the table. What does this mean? You are authorized to come in. Okay. Now, this is for a genuine user. But somebody who is a hacker and he is aware, or she, usually he, but there are some she's. Okay, So let's just use he. Okay, he is aware of this SQL injection attacks. What they will do, instead of giving you CS, have a look at this. Instead of giving you CS as the username, what they will pass you as the username is something like this. They will put quotation they will give you quotation or 1 equal 1, and they will put this. So what they did, because they are aware of this, they will close your quotation, so your query is not upset. They will add a true condition that is always true. 1 equal 1, always true. And they will concatenate it or connect it with an OR. So what will happen is, when I run this, what I will get? I will get everything. What is it? Sorry, I here. This is an example of SQL injection. It does not stop there, of course. I can do here, select, star from, just course. Let's try. I'm not sure if it will work in this scenario. Yes, you see here, 2. Yeah, here, of course, this is not very interesting. It could be account. It could be salary. If you are curious, just curious. This is a curious attacker. And they don't want to do any harm. They are just curious. Okay. So you can see, very, very easy attack. Very, very easy. You just send quotation or another query, another always true, semicolon, and you can put another query. And you can try. They try. They are not worried. They try, and until they get it. A lot of effort, but they will get there at a certain stage. Okay. Once here, have a look at this. They can even do something like this. Update. App.stuff. Set. Set password equals admin, for example, where usually they know there is an admin user. They can take over the admin. Very easily, they can take over the administrator of the whole thing. They will try. They will say, okay, maybe there is a user admin or administrator or root or SA. They will try all type of combinations. But because this is an attack that can go for days or hours or years. So they try to really be very careful and slowly try to discover as much as they can. As they discover, they download. And then they post somewhere and share with their friends. So in here, I will say here where password is admin, where username is equal AUP. Let's say AUP is the administrator. So I can just run this. Of course, if I run it again, AUP, can somebody see AUP? Where is it? Yes, it's still password because this is the first time. When I run it again, did it change? You see here the password has changed to admin. Now, of course, they will target like a user, let's say admin or manager. They will try a couple of things. Or maybe they know somebody in the organization. They know that the organization uses surname as the username or first letter of the first name dot the surname, and they will go and target that. They try to imitate that user, especially some big guy that have lots of access. And now, khalas, they have admin. They will go to the user interface, and then they log in as admin and do whatever they wish. That is fine. It takes, let's say, because remember, these guys, they like to do their work at night. Everybody's sleeping, and that's what they enjoy. They sleep during the day, and they are awake at night. This administrator, of course, they are sleeping. By the time they wake up, it's already on the news. So you see the idea. It's very simple, but very dangerous. Okay, so let me show you another example of this. Another example. You remember I told you there is this OWASP. They create some applications that are insecure to teach you these threats in concrete way, not just talking about it. And they show you examples of how to break it and how to fix it. So that's why you learn. So in Node.js, in different platforms, you have in Java, in .NET, in different platforms. Of course, Node.js is very popular. So they created this application called the NodeGoat. And it's open source in GitHub. I sent you the link in the email I sent a couple of times. So what you do, let me see if it's running. Yes, it is running. So it is listening on port 4000. Come on. Okay, let me just come here. Close 4000. Okay, let me just stop it. Run it again. Node server .js. So this hopefully will start the server. It's listening on port 4000. So let me go back, try it again. Okay, here is the login page. And there is the user one, password is user1_1234. This is all in the documentation. So submit. So this will log me in. Don't worry about this. Now let me show you an example of SQL injection, not SQL injection. It is an injection, but not targeting SQL Server. It's targeting JavaScript runtime engine. So, of course, the hackers, whenever they see some input box, they will try to put some commands. Hopefully, there is some interpreter behind this box that will receive their command and execute it. Okay. This is a little bit extreme, but anyway, just to demonstrate the idea. And I'll show you why it breaks. So what I will do, I will just call here process.kill process ID. I'm asking the server to kill itself. So this is an example of denial of service attack. The server will shut down. So in here, instead of putting employee pre-tax percentage, I give it this command. Okay, and then press submit. Okay, basically the server is down. That's it. See, server is gone. So, and the reason why it's gone is basically if I look at this, of course, this developer, they better hide themselves or they will be fired. So here is the app, I think, under, let's see. Let me see, I think I documented here. Under contributions, eval, okay, contributions. Yes, not this one. Yes, here, contributions. You see, this guy, for some reason, they are, remember, we have a form. And that form, when I submit it, the fields that I submit will be available in the body. Okay? So instead of doing parse int, the way you did it before, if you are expecting an integer, you receive it, and then you do parse int to read it as a string. So this guy, they like eval instead. Eval is you basically give it a string, and it executes it, whatever it might be. So here I am sending it process.kill process.pid, which means kill the current process. And this eval is basically it's an interpreter. It basically takes a string, executes it. It doesn't care what that string has. So this is another example of injection. So injection is really whenever you have an interpreter that takes some kind of string and executes it, you need to be very careful. Because if the input coming in and you feed it to the interpreter, of course, the hacker will try to inject some unintended commands that you didn't even think of them. And that's what they do. And let me show you how they can get into, let me first restart the server. Of course, this is after the administrator wakes up and they get a phone call, hurry up, come, the server is down. Of course, if it is a big site, it's a huge problem. They have lost a couple of millions and a couple of customers and everybody is upset. Of course, directors are waked up, everybody. That poor developer, they hurt themselves. Okay, so here it is. So let me run this. So here is the server up again. And let me go back. Of course, it will throw me to the login. They did good job. Whenever I come, I have to log in. Okay, so let me show you contributions again. Sorry, I will remove that. Sorry, I will just quickly remove. This is another type of injection. I don't know. Whatever. Let me just save it. So it just stop annoying us. Now in here, what I will do, I will try now. I will try to ask it to give me the files on the server at the current folder. And then I can, of course, hackers, they guess with expertise, they have their own forums where they share expertise. And there is some common patterns people use. Of course, they try to leverage that. And they know some servers, they have some default location where they put some sensitive data. So they are aware, each server, they know that this is Node.js or Java, and they know the folder structure and they know the weaknesses. Of course, they do their homework. Don't worry about that. All right. So here, what I'm asking, let me show you what this is doing. I'm asking, bring in the file server library. They are aware of FS, Node.js people. In a synchronous way, get me all the folders in the current location. And I want you to give them to me as a string. So copy this, and I paste it here, and submit. These are the files in that folder. Of course, this is like a WikiLeaks. This is the folders. Now I can go into the files. This is a folder. I can go to the subfolder, drill down there, and ask what is in that folder. All right, and slowly bring in gigabytes of information from this website. So in here, I'm interested. I find some very interesting file that I want to see what's in there. I send a read file, sync, and make it a string. So I'll copy this. So it's a process of discovery, gradual discovery, until they tap into something valuable. And of course, they invite their friends. Yes. Yes. Okay. All right. So submit. This is the content of that file. Okay. So that's the idea. And all of this, because of that eval, that's evil. See here. This is this guy that's doing all of this. Because this one is an interpreter open to injection. Injection means the hacker is sending like commands that are basically malicious commands. And the poor interpreter basically takes them and executes them. Okay? This is very common and very dangerous. So how do we avoid this? Sorry? By?
Here, for example, we have value.
Mm-hmm.
So yeah, we just take the value. And we do the parsing, like we said.
Yes. First of all, whenever it's possible not to use an interpreter, we don't use it. That's first thing. Okay? Whenever. For example, here, it doesn't make any sense to use this. There's a much better way of extracting information from a particular incoming attribute. Okay, that's number one. Second one, what else you can do? Validation. Validation is very, very important. Input validation. Not only on the client side, by the way. The client side, you know, there are plugins you can disable all validations. Not only this, you know, you can interact with the server using something like Postman. You don't even have an interface. There's no validation. It's open door. You just send it a JSON object and it does the work for you. So validation on the client side is good, but not enough. You need to do validation on the client side. For example, here, even if this guy, they only know eval and they love using it, when they, it's a bit hard. Before they do it, they have to verify. If this is a number, I'm expecting this to be a number. Khalas, if you don't give me a number, I will not do the next step. Okay, that's what I mean by validation. You validate it. You can do also what is known as blacklisting and whitelisting. Blacklisting means if the string has any of these commands or any of these keywords, reject it. Say no, I'm not going to do it. This is if you have no choice but to use that interpreter. So what you can do, you can either blacklist. You have some kind of list of stuff that are not allowed, and you just bring the string and you say, this string, does it have any of these blacklisted words? If yes, you say, no, I'm not going to do it for you. Or you whitelist. You say, I only accept these. If you give me other than these commands that I have in my whitelist, I will not do it for you. Okay? So it's all validation, as you will see. In most of these attacks, validation is critical. Very, very important. Okay? Now, for SQL injection, never use concatenation, concatenating parameters using plus or concatenate with the string. Never do that. Always use set parameters. Remember that set parameters? We had it. Here it is, this one. Of course, you do validation, of course, and you do set param. You see here, what I'm doing here, I create a parameter. Here, see? I didn't use concatenation. I set the parameter, I define a parameter, and then I set it, then I execute. So this is not subject to that. It's not, if you do it this way, even if they try to do that injection, it will not work for them. Okay? But if you do concatenation, it will be a problem. Okay? So you have validation, you have using set parameters. And maybe, I'm not sure, in the database you've seen store procedures or a function that you store in the database, and then you pass parameters to it. It cannot do anything other than executing your query using parameters. Okay? So as soon, basically try, if you have an interpreter, try to avoid using concatenation with the input strings that you pass to your interpreter. Validate those parameters and avoid, as much as possible, avoid the concatenation. Okay, so I hope this one is kind of clear. Let me just go through it again. So basically you have some kind of interpreter that receives a string, and the hacker tries to send some send some attachments to be executed by your interpreter. So here is the solution. Validate the input. Escape values. Escape values here, what it means is there is what do we call it in HTML? Encoding. There are functions that does what is known as encoding. Encoding is changing certain characters with equivalent ones. So for example, the percentage, let me show you. Let me try to see if I can find some encoder here. HTML. Yes. HTML encoder. Online encoder. Just to see, all right, this guy didn't want. Okay, no problem. Let me show you another way. For example, if I come here and say Qatar University, see here it has a space in between, but when it's added to the query, the space has been replaced by plus. Okay, so this is called encoding. So certain characters are replaced by other equivalent characters, and usually those other characters are much safer than the original ones. Okay, so you try to encode. So you basically kind of undoing the harm that the user this attacker is trying to do. So, for example, let me see. Let me just see here HTML encoding. Table, just to show you examples of these encodings. Okay, this hopefully will give us. Yes, you see here, these characters will be replaced by these. Okay, of course there are more. So if you take the input and you encode it, those characters that you are not usually expecting. Username has just A, B, C, D, 1, 2, 3, 4, 5. Any other weird characters will be replaced by these numbers that even if you concatenate them, there is no risk. You get the idea. So encoding is another mechanism to avoid this injection. Use parameterized queries, as I told you. Enforced least privilege when accessing a DB and OS. So remember, your application will be running under certain user. Okay, you try to give that user the least privileges. You know how when you want to run a query against database, you log in as a username and password. Like for example, remember you do app for that application. Of course, that app is an administrator. They have access to everything. So in a real application, you log in using a user that has the least privileges required. Only a couple of privileges, maybe just to execute a couple of tables or a couple of queries. Don't log in as a user that has everything. Because even if you are compromised and they try to do something, let's say drop a table or update or whatever, that user will not have access and it will fail. So that's another mechanism. Okay, inshallah next time I will explain further. So what is left is like it will go like this. We go through these risks, explain each one, and explain how we can avoid them. Okay, thank you. Assalamu alaikum.